In this video, we will learn how can we calculate the expected value and the variance for discrete probability distribution. So the expected value or mean of a random variable is measured of its central location. So we've already covered it in chapter 3 about different numeric measures for random variable. And so we will use this formula to get our expected value or mean for the discrete random variable. And so the E stands for expected value. So it's the initial word of expected value of x equal to mu. So we learned this letter before. It's a Greek letter, which means it's the letter for the population. And again, no matter what kind of how many sample we get it, if we assume it's from the population, and if we draw them from the population, and we will assume the sample and population following exactly the same probability distribution. So that's why here we can use the mu, and it's equal to each. It's a weighted average of the value of the random variable. May assume the weight of the probability. So here, as we mentioned before, the fx is what we call it, is our probability for the corresponding outcome of x. So each x multiply its probability and add all the possible pair together, and we'll get an expected value. So here we will treat the fx as the weight for the possible outcome of random variable. The expected value does not have to be a value the random variable can assume. So later we will look at example to have the better understanding why the expected value does not have to be a value the random variable can assume. Before we keep moving on, let me use an example to understand how can you expand this expression. So for instance, and let's see, the possible x value is x1, x2, x3, x4. So the possible x value is x1, x2, x3, and x4. And then now we are looking at the expectation of x. So in order to get that, we also need to know the probability for the x equal to x1. So let's say the probability of x equal to x1 is fx1, and the probability of x equal to x2 is fx2. So we can see the last one, x4, is the probability x equal to x4. So now, given the information we know, the possible outcome for x and the corresponding probabilities, now we can calculate the expected value of x. So expected value of x equal to what? So given this formula, we will know it actually is equal to x1 times fx1 plus x2 times fx2 plus x3 fx3 plus x4 fx4. So that is how we calculate the mean. So in the following slide, we will see another example, and it will show you how can you get the probability. So once we know the variance, we know the mean or the expected value, we can start to calculate the variance and the standard deviation. So the variance summarizes the variability in the value of the random variable. So the variance of the random variable x equal to sigma squared. So we see it before. Actually, it's equal to x1. It's the observation minus mean, which is calculated powered by 2, and times the probability corresponding to the outcome, and we will add all of possible x value together. So again, let me show you how can you get the variance according to this formula. So we're still using the old example. So So the possible value for x1 is x1, x2, x3, and x4, and the possible probability corresponding to each possible outcome of x is fx1, fx2, fx3, and fx4. And we know we calculated mu before, so mu is calculated. So now we can do, say, we want to calculate the variance for x. So what we are doing is we use x1 minus mu times, and then powered by 2, don't forget all, powered by fx1, plus x2 minus mu powered by 2 times fx2, plus x3 minus mu powered by 2 times fx3, plus x4 minus mu powered by 2 times fx4. So this is the formula for us to you need to use to calculate variance for x when we have four possible outcomes for random variable x. So the variance is a weighted average of the square deviation of the random variable from its mean. The weight are the probability. So again, we treat fx as our weight. So the standard deviation sigma is defined as the positive square root of the variance. So everything are the same. The only thing you need to know is how should you understand fx is a probability for each possible outcome. So now let's look at example. So we use the GSL appliance again. So before we've already calculated we already know the possible outcome for x. So the possible TV sold in the days from 0 to 4. Based on the frequency, how many days sold 0 TV within 200 days, and we can calculate the frequency. Then we use each x, multiply its corresponding probability, and we got SFS. So then we add all of them together. We got the expected value for x. So actually try to think about what I just showed you. The expectation of x equal to what? Equal to x1 times fx1 plus x2 times fx2 plus x3 times fx3 plus x4 fx4. So actually this part, if you try, actually is doing this kind of calculation. So the final answer 1.2, and we were expected the number of TV sold in the day is 1.2. So again, so 1.2 is none. So none of this outcome is equal to 1.2. Again, this result proves what I said before. The mean may not be the possible outcome for x. So how about the variance? So the variance, when we do the calculation, since we already know the mean is 1.2, and we use each possible x minus mu, and we got this one, and powered by 2, and times fx, which is the weight for the deviation variabilities, and then we add all of them together. We got 1.66. So the variance of the daily sale is 1.66. Now we can go further to calculate the standard deviation. What we are doing is positive square root of 1.660, and we should get 1.2884. So to end up this section, we want to look at how can we use Excel to get our final answer. So for instance, we already know the sale and the probability, and what we are doing is first we need to calculate one more column which we will use to calculate the variance. So this part what we are doing here is trying to get x1 minus mu powered by 2. So we are getting this part in the formula. So we create 3 columns, And then we can use a function called sum product. So what they are doing is the first entry before the comma, so from A2 to A6 is our x. So that is the value for the possible x. From A2 to B2 to B6 is our weight. Or in our class we also mentioned this is the probability. And then we will using this function to calculate the sum x minus mu fx. And for the second part, we're trying to get a variance. So again, C2 to C6, we just calculated it's the value for the x, each individual observation from mean, the distance powered by 2. And the second part, this is the weight, the probability distribution. So what we are doing is x minus mu powered by 2 fx. So here there is an arrow. So here should be summation of x fx. So we'll calculate the mean. So here we are doing the variance, so powered by 2. So the last one we got standard deviation, and we know it's a positive square root of variance. So using the Excel, it will help us to get the answer very quickly. So now we got exactly the same answer. The mean equal to 1.2, the variance equal to 1.66, and standard deviation equal to 1.2884.